Okay, this is the video to fill in your factoring flowchart. Now I'm going to go over all the methods of factoring, but in very little detail, just kind of skim over them. This is a video to help you know when to use which method depending on what you're given. If you need more detail on any of these methods, refer to one of my other videos. Okay, so you would start here and you would look at the problem that you're given, and the first thing you're going to do when you get a problem is factor out the GCF if possible, or a -1 if A is negative. And remember that when we're working with a quadratic, for instance, we would have the first term's A, so ax squared plus bx plus c. So if this is negative, or if this is, if there's a GCF that you can factor out of all three, the first thing you'd want to do is factor it out. An example of that right now, but we will practice this in class. So if it's possible, you go ahead and do that, and then you can go to the next box. In the next box, to determine if the polynomial that you're given, is it a difference of squares or a perfect square trinomial? Okay, if it's no, we're going to head this way, but for now we're going to go into each of these boxes. I'm not giving you an example, we're just going to fill it out and give you an example in each box. Okay, so let's say that you determine that it is in fact a difference of squares, and now I'm going to give you an example. X squared minus 9. This is a difference of squares. Again, if you need more specific information, you're going to have to go to the difference of squares video. But this is a difference of squares because this one's a perfect square, this one is a perfect square, and I'm subtracting them. So how would I factor this? Well, the first thing you need to know is that you're going to factor it into two binomials. Okay, so I'm going to set that up. I wrote it down here so that way I have room to actually factor it here. I might even move it up some. That's all the space I'm going to need. Okay, so factor into two binomials. So I set that up. These are going to have my binomials in them. Okay, find the square root of each term. One binomial is going to have the plus sign, and one binomial is going to have the minus sign. So we take the square root of each term. So what I'm saying here is take the square root of this. X squared, if I take the square root of it, would be x. I'm going to put it in each of the binomials. And then the square root of 9 would be 3. And I'm going to put it into each. But I can't write this as one binomial because one needs to be plus and one needs to be minus. Doesn't matter which one is which. So plus and minus. There we go. Here is our factored difference of squares problem. Okay, so is it a difference of squares or a perfect square trinomial? Let's see what would happen if it's a perfect square trinomial. Okay, so if it's a perfect square trinomial, here is an example of a perfect square trinomial. Okay, if you don't know how to recognize a perfect square trinomial, you'll have to refer to another video to find out what a perfect square trinomial is, but this is one. I'm going to briefly tell you, but there won't be enough room in here to give you all the notes. But the first term needs to be a perfect square, the last term needs to be a perfect square, and then the middle term is the square root of the first term times the square root of the last term times 2. This can always just be factored as you would a typical trinomial. But if you do recognize that it's a perfect square trinomial, it's just a shortcut to get to the end. Okay, it's going to factor into one binomial that is squared. So I'm going to leave a little space here for my work. But one binomial is going to go in these parentheses, and that binomial is squared. Okay, so to factor this, I actually don't need work. I was thinking I needed some, but I don't. To factor this, you would need the square root of the first term. So x squared, the square root of that is x. The square root of the last term, square root of 9 is 3. And then the sign on the middle term. So there we go. This is this factored. And I'm going to prove that to you really quick. So we have x minus 3 squared. Okay, if I have x minus 3 squared, I can't just hit both of these with the squared. I actually would have to change this to x minus 3 times x minus 3. So I multiply these together, I get x squared. I multiply these together, I get negative 3x. I multiply these together, I get negative 3x. And then last, negative 3 times negative 3 is a positive 9. Combine the middle terms, and I have x squared minus 6x plus 9. And that's why you'll always end up with a perfect square trinomial if you take the square root of the first term, which is x, times the square root of the last term, which is 3, and multiply it by 2. That's how you end up with the middle term. And only this term can be negative. Again, refer back to Perfect Squares trinomial video, or special cases video, if you want to learn more about those. Okay, so that's a perfect square trinomial. So what if it's no? So if it's no, then we're going to move on to the next box. Is it a trinomial? So now we're going to look at it and decide if it has 3 terms. If it has 3 terms, there's 2 different ways we can factor it, but we have to ask ourselves another question. To know if a equals 1 or is a greater than 1, meaning does a have a number or does the first term have a number in front of it? So we're going to do each of those in each of these 2 boxes here. Okay, when a equals 1, you won't see anything in front of the x here because that's just 1 times x squared, and we usually drop the 1. So if a equals 1, you're going to factor into 2 binomials, and you're going to use the I-bar method. Okay, and if you need more detail, you'll have to refer to one of my other videos. But the I-bar method is just an organizational graphic organizer where on top we take a times c, and on the bottom we come up with b, and in the middle we're going to come up with all the factors. We want factors of a times c right here, and we're going to see if they add up to b. Okay, it's something that some people have learned how to do in their heads, and other people like to use this method here. So I'm going to use this method. And I have a times c. So a is 1, c is negative 24. So up top I'm going to put negative 24. And on the bottom, I'm going to put b. My b is negative 2. And now I just need to come up with factors. So this space here is just room to come up with factors. So I know that 2 times 12 equals 24. And now I need to see, is there any way I can add or subtract 2 and 12 to come up with 2? Well, there's not any way I can add or subtract those to come up with 2. So now I'm thinking, well, I know 3 goes in there, so I'm going to try 3. It's just a way to make a list. And 8. Well, 3 and 8, there's also no way for me to add them to 2. So now let me try 4 and 6. Well, 4 and 6 can subtract 2, so I just need to figure out where my negative goes. So all this is a list, so that way we have a list of what you've already tried and what didn't work. So something needs to be negative because when I multiply them together, it's negative, and then they need to subtract to negative 2. So that means that the 6 needs to be the negative one, because now I have 4 times negative 6 equals negative 24, or 4 minus 2 equals negative 2. So my magic numbers here are 4 and negative 6. So I just need to go ahead and put them in the set of parentheses here. I'm going to have x plus 4 and x minus 6. This is the factored form of this trinomial. Okay, so what about when a is greater than 1? Well, I'm going to zoom in here to just this section. So a is greater than 1, so I can write a little bit more easily. Okay, so long as you did the first step in our flow chart, let me flip back to that really quick, factor out the GCF if possible, then you would use this method. So for instance, if this 2 could be factored out of all of them, you'd want to factor that out first, but that's not possible here. So we're just going to go ahead and factor this as is. Okay, so compared to our last one, where we just used the I-bar method and then we got them right into our 2 binomials, here we're going to use the I-bar method to split the middle term. Okay, and after we do that, we can either use the box method or grouping to factor this completely. And so I'm going to show you the box method here, and then we'll see grouping when we get to this last one here. So I-bar method. Once again, we're just using the I-bar to come up with our magic numbers. So it's just a graphic organizer. So a times c is 24. B is negative 11. And now I'm going to come up with some factors. I could do 1 and 24, but I know it's pretty far away from adding to 11. So let me try 2 and 12. Okay, 2 and 12, there's no way I can add these or subtract these and get 11. So next I'm going to try, let's go with 3 and 8. So 3 and 8. Well, 3 and 8 could add to 11. I just need to figure out what's going on with my negative signs. So they need to multiply to a positive 24. That means that they both need to be negative. That way they would add to a negative 11. All right, so this is where it's different though. We're going to split the middle term. So all that means is I'm going to rewrite this and go 2x squared minus 3x minus 8x and then plus 12. So you can see this middle term here, get a different color, became this. Because negative 8x minus 3x or negative 3x minus 8x would combine to that. So I just took this and split it, but I had to split it with these specific numbers, and I used the I-bar method to figure out which numbers would split it the way I wanted to. Okay, so now I'm going to show you the box method in this square, or this rectangle. So the box method goes like this, and for more detail, see one of my previous videos. But the first term is going to go in the first box. The last term is going to go into the last box. The middle terms are going to be split into these two boxes. It doesn't matter where these two terms go. It's only the first and last that matter. And now I'm going to use this to factor out. So I'm going to factor out this way, and I'm going to factor out up. And the way I figure out my signs is the box that's closest to the edge tells me the sign. So for instance, this is going to be positive, and it should always be positive because my first step was to factor out any negatives with a negative 1. So this is going to be positive, this term's going to be negative. This is going to be positive, this term's going to be negative. Now I already know what they're going to be. So what can be factored out of 2x squared and a negative 3x? Well, it's going to be positive. I don't care if this is negative, and what I can pull out is an x. Here I can pull out a 4. So I have x minus 4. Now I'm going to factor up. I can pull out of 2 and 8, can come out of 2, goes into both of those. And out of x squared and x is an x. Okay, and then lastly here, out of 3 and 12, I can pull out 3. And there's only an x in this box, there's not an x in this box, so I cannot pull out an x. I now have my two binomials. This is going to be x minus 4, I got from right here, and then 2x minus 3. There we go. All right, so you should have filled that in here. Now we have one more possibility. So at this point, you've traveled down the line, you've factored out any GCFs, you saw that it was not a difference of squares or a perfect squared trinomial. You also saw that it is not a trinomial, and so you've reached the end. Is it a 4-term polynomial? If this polynomial that you're looking at is factorable, this is our last chance to factor it using these methods. Okay, so we've determined, ooh, this is in the wrong spot. I need to fix that. I will fix that on your notes. But this should not be here. It should be here. Okay, so it's a 4-term polynomial. Let's zoom in again. Okay, so here's a 4-term polynomial for us to work with. Okay, so I can either group into binomials and factor, or I can use the box method. And this one I'm going to show you both. But back here where it said or grouping to factor, that's what I'm going to show you first, is to group to factor. Because this is 4 terms, 1, 2, 3, 4. And once you split the middle term over here, this is also 4 terms, 1, 2, 3, 4. So you could have used grouping back here. But I decided to use the box method. So let's go ahead and use grouping for this one. So what this means is you're going to group what you have here into 2 binomials. And this negative sign there in the middle is going to stay with the 30, negative 30x. Okay, and now I'm just going to factor out of each of these. So I'm looking for something that will come out of 12x cubed and 2x squared. Well, I know I can pull a 2 out from 12 and 2. So I'm going to pull out a 2. And then I can pull out an x, but I need the highest degree possible. So if I have a 3 and a 2, the highest I could pull out is the 2. So the highest degree possible would actually be the lowest degree there, because I can't pull out a 3 if this one doesn't have 3 x's. All right, so I'm going to pull out 2. And then I need to figure out what's still inside. Well, I divide this, and I have 6x. And then I divide this, and 2x squared divided by 2x squared would just be 1. Now I'm going to do the same for this one. negative 30x minus 5. Well, I'm going to pull out a negative 5 out of both of these. So negative 5. And then divide them. So there's no, I'm sorry, let's back up. There's no x. There is not an x in both of them, so I cannot pull out an x. So negative 30 divided by negative 5 is going to be a positive 6x. And then negative 5 divided by a negative 5 is plus 1. Well, what should happen here is that these are going to match. What's inside of the parentheses are going to match if this is factorable and you did it correctly. So now this is one term. This whole thing is one term. And this whole thing is one term. So what I'm going to do is I'm going to pull out what matches. Just like here, I can pull out an x out of both of them because they both have it. Well, here I can pull out this 6x plus 1 from both of them. So I'm going to pull out 6x plus 1. Put that right there. What's left when I divide this term by 6x plus 1? Well, they would cancel out, so I would have 2x squared. So right from there. And then if I were to take this term and divide it by 6x plus 1, I would have negative 5. So there we go. If you're familiar with this, use this. If you're not familiar with this and prefer the box method, I know lots of people who like that one instead. Use the box method. So now I'm going to show you the box method for the same one, but this is the answer. In the box method, you always need 4 terms. The first term is going to go in the first box, so 12x cubed, 12x cubed. The last term is going to go in the last box, negative 5. And now it doesn't matter which box these go in, but just pick. So I'll go 2x squared here and negative 30. Keep that sign with it right there. I'm going to go ahead and figure out the signs right away. Because this is positive, this is going to be positive, so I'll write plus. Because this is negative, this term's going to be negative. This one should always be positive if you already factored out the negative on your first step in the flow chart. So let's see, what can I pull out of both 12 and 30? I can pull a 6 out of both of those. And then what can I pull out of both x cubed and x? Well, just x to the power of 1, because I need the lowest exponent here. And now coming down here, what can I pull out of both of these? Well, 2 and 5 do not have a factor that I can pull out other than 1, and there's only an x in this one. So the only thing I can pull out here is a 1. Well, this is looking like it's right. So my first binomial here is 6x plus 1. And now I'm going to pull something out up here. So 12 and 2, what can I pull out of both of those? Well, I can pull a 2 out of both of them. I can also pull out an x squared from both of these. And then coming over here, I can pull a 5 out of these. And that is what we got above as well. So 2x squared minus 5. Okay, so all of this should be now filled out with the parts that we zoomed in. I'm not going to give you any problems to do for now. We will try them in class. Let me know if you have any specific questions, but we will use all of these methods in class. It'll be mixed up the type of problems that you'll be given, and you have to figure out which method to use.